Hello there. Thanks for coming this morning. My name's Jonathan Forbes. I'm from Aquila Insight. Joining me on stage, Pugh-Jones from SAS. We're going to talk a little bit about big data. Could I make a plea right at the beginning of this? I'd like to propose, and I'd like you to vote. I'd like to propose that we stop calling this big data, and we just call it data. If you agree, could you raise your hands? Right, we'll just call it data. Thank you very much. Good. Done with the subject. We're going to talk a little bit, really from two ends of the spectrum. The storage, processing, analysis of large data sets. Peter's then going to talk about streaming analytics, how to cope with a world that's continuously sending you bits of data, and how to pull the signal out of the noise. I'm going to talk a little bit about systems that we use inside Aquila Insight, distributed analytics we call it, which is the combination of Hadoop and Spark and R that we've mingled in with a revolutionary new technology called SQL. This really works for us and our clients, the people we work with and work for, because they have teams of analysts that live and breathe SQL. They've grown up on it, they've been trained on it, they've been educated on it. The limitations, obviously, of relational databases when it comes to large data sets and fast-moving data and different varieties of data have kind of excluded them unless they were prepared to get in and start writing code in Java and Scala and all the rest of it. Many of them aren't really at that point, so this is a way where we can combine their curiosity and their need to provide insight for their businesses with the capability to process very large, very fast-moving sets of data. So for us, we're really at a sort of new phase. For me, we're not proposing, by the way, here that at the end of the second phase, everybody threw out what they had and started on the third phase. This is an evolution and a transition. Going from business intelligence through big data, I didn't know that was in my slide pack, by the way, having banned it at the start of the talk. I need to sort that out. Yeah. And we're now into these different tools for managing large data sets distributed across many machines. And that's really that's really all I'd describe it as. It's just a different set of tools to try and achieve the same objective of, I think it was Stephen mentioned it earlier, I don't want a quarter-inch drill, I want a quarter-inch hole. I don't want the big pile of infrastructure, I want the insight into my business. So we're going to do a little bit of stuff today. We're going to talk about some data sources, really quite interesting data sources, large-scale, fast-moving-ish. We're going to talk about some of the machines, the machinery that we use to do, or can use to do this. We're going to look at some code, very briefly, because I know we're running a little bit behind, so we'll not do too much on the code, but it's all there if you want to see it. And we may even draw a chart or two, because that's what analysts do when they're trying to get their insights across. So, in a little bit more detail, we're going to collect together all the world's news since 1979. Not really going to collect it, we're going to take slices of it. We're going to collect all the world's airline data in America, all commercial flights in America from 87 to 2008. Find something interesting in it, draw some pictures. And we're going to use a standard set of tools for us, open source tools. RStudio, Apache's Hadoop, the original Spark. Some clusters in a cloud somewhere, suitably. Not the fastest way to do things, I'll agree. Putting, even with placement groups in the cloud, you can't guarantee, Hadoop and various other big data systems are very sensitive to rack location and network bandwidth and so on. But this is a great way of playing to the theme of why we're here, which is play, inspire, learn. You can do experiments with this stuff yourself when you go home. It's that easy. So these are our two data sources for some of the things that you'll see in a minute. A fabulous resource called GDELT, the Global Database of Events, Locations, and Tone. If you haven't had a chance to find out a little bit about what GDELT does, please do. It's now backed by by Google, and it's used, some of the insights it generates are really, really quite interesting. We'll see one or two of them. The other one I'm going to do is, because I can't show you big piles of customer data, they don't like it. We're going to look through a few hundred, it's 100 odd million records of US flights, and we're going to try and do it with a use case given to us by many of our customers, which they call sort of train of thought analysis, which is, we don't really know what the question is at this point that we want to ask. We just have these enormous piles of data, and we think there's something useful in it. Can you help us get to the bottom of it? So this is a mechanism, this is a way that we deploy, that we use to help them through that process. So these are our core building blocks. RStudio and the server edition, because we've got teams of analysts working together on things, some libraries. All downloadable, by the way, in an afternoon, configurable, and it might take a day, 2 days if you're uncomfortable working in Linux. It's a good learning experience. We're going to use Revolution Analytics, open source version of R, because it's quite fast, particularly with the math kernel libraries. We're using it. At the time I wrote this talk anyway, we were using the most up-to-date version of Spark. There's a new version, 1.5, that's out. It's got some really good stuff for us in it. We're using 2.6 of Hadoop, so we're one version behind. All running on Linux servers. This is really low cost, easy to use, easy to deploy stuff, commodity stuff. We threw Spark into this picture because Spark really does, because it's in memory rather than on disk, it really does speed things up a little. It's still not as fast as it could be, both the software itself and the way I've deployed it in this particular cluster. So we know that there's performance improvements that can be had there. So here's some code. I'm not going to spend too long on it. We'll show you some pictures in a second. But basically, what this lump of code is doing is it's going out to the web. It's pulling a slice of data for the 1st and the 2nd of July. It's storing it locally at the minute. This is the demo code. There's a cluster version of this one. It's pulling out some what are called event codes. Event codes tell you what type of information it is that you've downloaded. And the information we're looking at here is economic and humanitarian aid between a particular time period across the world. We're then going to pull in a map. Can't do analytics without having a map these days. We'll even color it so it looks reasonably presentable. Stephen and Stephen earlier, and any UX people in the audience, I might offend your sensibilities in the slides to come, forgive me. And we'll do some timing at the end of it. And because some of these jobs, analytics jobs can take seconds, minutes, hours, or days, sometimes there's a little alerting process at the bottom. The end of the script that just zaps my mobile phone and tells me that it's finished doing things. So that's what the output of that half a dozen or a couple of dozen lines of code is. Maybe even just a dozen lines of code. These are reports from across the world based on the GDELT data set. Between 2 days in July, there's about 500,000 raw source events aggregated up, displayed on a map. And clearly, somebody up in the Baltic states is talking big time about economic and humanitarian aid. So what? Well, it's an insight into what's happening in particular regions, geographic regions. And it's been arrived at in the space of a few minutes of processing. So clearly, we can now look at we have a source of macro data about what might be happening in particular areas of the world. And we can do the same again, but this time pulling down a different event code and looking at sources of data. This is not sentiment analysis, this is just more like raw data sets being pulled from local news sources, for example. And we can see that if you were planning some of the trips, travel journeys you saw earlier, if you're planning a trip anywhere, you probably want to avoid Korea. Probably knew that anyway. Okay, so a couple of lumps of code, a few dozen lines of code, a couple of clusters, setup of half a day. and you've got access to pretty much everything that's happening in the world of newsworthy significance, whatever that means, on a cluster and can process it in minutes. It's pretty powerful stuff. So now we're going to switch on to something that tests another little bit of this approach, which is we're looking at it's not a huge data set, this one. It's slightly over 100 million, I think 123 million records. Throw in some additional tables to look things up from, and you get some interesting cumulative effects. Again, here we're pulling data from a Hadoop cluster. We're then processing it on a Spark cluster. So the data is being stored on Hadoop. It's being lifted out of HDFS. It's being put into memory on a Spark cluster. It's then being treated over on the right-hand side there. It's being treated effectively as database tables. Now, there's no ETL pipeline for this stuff. These are just files coming in, CSV files coming in, being read and being processed pretty much as they arrived. These are CSV format, which is the lingua franca of much of analytics today. And some of the nice things we can do with it, having read in this raw data from files and not really knowing where to begin with it because it's just arrived. Down in green, down at the bottom there, we can have a look at the schema for the data. So just pulling out the different tables, looking at what is actually in the data. That's very important. This EDA, exploratory data analysis, something that most analysts spend the bulk of their time doing. And the second biggest thing that analysts do is complain about the amount of time they have to spend doing exploratory data analysis. So here we have our performance figures. This is airline data. So these are flights taking off, landing in the US, how they performed, were they on time, were they delayed, et cetera, going back about 25-ish years, something like that. And we've got some airport data, and we've got some carrier data, and we've got some plane data over on the other side, sourced separately. So these are our reference points, if you like. So we've set up our Hadoop cluster on 2 slides ago, and this is the capability that we can now put in front of an analyst in an organization who's interested in studying their data. Write a query using SQL, which you've been doing all your life. Press the Go button. Show data frame, simple query. Sit back, wait till it finishes. Could take seconds, could take minutes. What it shouldn't do is take days and hours and days and months. And on the right-hand side, get some data out. So that's the aggregation of the data across all the flights counted across all the different years, aggregated by year. So pretty straightforward stuff. Arrived at in a handful of minutes, enough to go and get a coffee. That's significantly faster than many of our clients can do, but not as fast as some. Some of our clients will spend tens of millions of pounds and bring that number from a handful of minutes down to 15, 20 seconds. Tens of millions of pounds. Did I mention the tens of millions of pounds? This is on a commodity cluster in the cloud, expandable pretty much on a whim, costs maybe a few £100 to run on demand. Took a day and a half to set up, configure, and get running, and saved us tens of millions of pounds. So, slightly more complex query this time. So, selecting from a couple of different tables based on tail numbers, trying to then find out what type of aircraft are actually using it, when, what model they are, et cetera, et cetera. Again, for this particular cluster size, it only took about 4 minutes, 4 and a bit minutes. And similarly, slightly more complicated again. This time we're doing order buys and picking out certain dates worth of stuff. And this one was interesting from our perspective, or from my perspective, because this one showed me that all US commercial flights, or at least my data set, also included balloon flights, which is 340 of them actually in October 2006. So plenty of stuff that we can pull out. Last slide on the data itself. This time we're just doing some counts by year of different data types. Again, using standard SQL, plugged into an overall framework of a dozen lines of other stuff that can be templated in such a way that you just cut and paste it to make your query run. And that's great from an analyst. They love new stuff, but they've still got a job that they need to do at the end of it. And there you go, there's a chart. Some processing on the Spark cluster up in the top, and below it a chart that will have offended the sensibilities of all the UX people in the room. But that was the goal. The goal was simply to explore and find out what shape the data had, this massive data set, what shape it had, and arrived at in a few minutes. And for organizations that are trying to react quickly to what's happening in their markets, this kind of capability is obviously very useful and very welcome for them, because it allows them, for example, to optimize their prices based on what's happening during the day, during the minute, during the hour. Okay, so just a little bit of a heads up on the analytics of this one. Really the goal for us going down this path was not just to make it easy for analytics teams who are soaked in SQL and know it inside out. It was also to give them the tools to build models with. We're at that position now with a version of Spark called 1.5, or at least we're getting much closer to it. 1.4, the version used here, doesn't support the native modeling features that you get with R. What it means is that if you want to actually do some modeling based on a set of data, your workaround is to, in classic R style, as an analytics tool, is to just bring it down, slice it out, bring it down locally, and run all the native functions that you would normally get. And it's a simple one-line command to do it. Again, it can be templated. 1.5 of Spark is getting there with its modeling libraries. And you can, of course, run classic modeling, of course, on all this stuff, classic linear regressions, for example. And there's a nice tutorial presented at the recent KDD, runs for about 300 pages, but you can skip through it really quick to get to the good stuff. Worth a look if you've got a large data set that needs processing and insight quickly. All right, so this is where this last-ish slide kind of fits in, it shows you where this kind of approach fits into our overall platform architecture at Aquila Insight, the stuff that we give to our analysts and we give to our customers to work with. So top layer we have, this is a Lambda architecture pattern as it's called. Top layer is batch for pre-computed views. Bottom layer is the speed layer where data comes in. Data comes in concurrently to both layers. Having the speed layer allows us to process stuff in addition to the time gap that's taken when you have to batch process large jobs. And then over on the right-hand side where the analysts sit is where they run their queries against. They run them against both those sources. So you can see from some of the code that we did earlier, reaching into either of the two layers, either the Hadoop-based batch layer or the Spark-based speed layer, is as easy as joining up, querying some data from the files, and then writing a SQL query. Pretty straightforward and simple stuff. So, my conclusion, I'm going to hand over to Peter in a second to talk a little bit about the streaming part, which is a really exciting part of bringing data into your system. We think the third phase is here. It does work. It's easily testable. If you have existing skills in the SQL space, this is easy for you to use. You shouldn't have to worry about the size of the data sets that you're bringing in to your organization potentially. That certainly keeps many data architects awake at night. It shouldn't anymore. The way we work, we find it really efficient to have analytics engineers working closely with data analysts, because you can make an awful lot of difference configuring your cluster, which is a fairly quick job, and you can make an analyst's life that much easier by doing it. So it's not really, it's like a performance engine in some senses. If you tune it one way, it works really, really well for one task. If you tune it another way, it works really well for another one. Your ideal analyst is capable of managing clusters and tuning them. There aren't too many ideal analysts. Put an analytics engineer beside them, and you've got a really powerful combination. That's everybody who's contributed to this. That was all open source. Everything you saw up there was open source. And that's everybody who's contributed to it. So there's a community out there, as I'm sure you're all aware and all use anyway, of people out there who've got your back when it comes to processing big data. Said that word again. All right. We've covered an awful lot. I've done it very quickly because I'm trying to pull things on time. I'm going to hand over to Peter now. We're going to try and effect some kind of exchange of equipment in some shape or form.
Yes, I think we're going to cue some slides at the back, hopefully. Okay. Yes, perfect.
Good stuff.
This could be interesting. And does this controller work for those slides? Thank you. Okay, that's good. So, thanks, Jonathan. Yeah, I'm Pugh-Jones. I'm from SAS. I'm not sure what people know about SAS as a company, so I'll just give you a very brief overview of that. SAS has been around for about 40 years. It's one of the largest privately owned software companies in the world, and it focuses predominantly on analytics, oddly enough. Most people do think of SAS as an analytical language. Actually, it has a language. There is a base SAS language that you can write code in. You write procs in there. You say what you want to do. And actually, there is one for proc SQL, so you can use your skills in SQL using that language as well. What I want to do is just lead into the streaming subject before we get to it by showing you a picture that's very similar, I hope, to what we just saw a few minutes ago. And the reason I want to do this is so that I can show you where streaming analytics fits within one of those big data architectures that we talked about. So it's actually really important to remember that you can go off and do your analytics. You can go and work on those things in a sort of offline mode. But at some point, you've got to think about industrializing that system and making it so that it's easy to scale, making it easily accessible. And I think where SAS has been focusing its efforts over the last few years is in working with the Hadoop infrastructure, which gives us that distributed storage and distributed processing capability, allowing us to embed, in certain cases, actually run the SAS kernel inside, embedded within the Hadoop distribution, which allows people not to have to move the data first before picking it up. But we also have an in-memory solution that sits on top of that called Laser. That's our analytical in-memory solution. And that allows us to run UI tools that does mean that in some cases, you may not be an analytical expert. You may not be someone who knows how to write that SAS code. You may not be someone who can go off and run complex SQL, but you might be someone who understands the data and what you want to achieve with that. And you can drag and drop and do sort of explorations of the data and create reports on that data, slicing and dicing it in real time from the in-memory capability. So one of the things that we're working very closely with people like Cloudera and Hortonworks and some of the other suppliers of the Hadoop layer or Hadoop distributions, so that we can ensure that SAS is used in the right place and that the other capabilities that people invest in, such as R and all the other things that they might want to use Spark, can also be complementary within that structure. But what's really important is that we're sort of industrializing it so that it can be used for business as usual process. I think that's quite important. So one of the things Jonathan mentioned was streaming being a big part of the story. Notice I haven't got big data on this slide. I've just got high performance platform. But it is really a story about large-scale data moving around, being stored, being processed and analyzed, and making users get to it as quickly as possible. If you were to hide, I usually do it with my arm. It's a very big screen. I haven't got a big enough arm. But if you hide all of the stuff at the lower half of that diagram, you could argue that if you've got lots of disparate data sources and streaming sources that you need to bring together somewhere, you could pick that data up from those locations, run them through a streaming engine like ESP, put them into an analytics in-memory solution like Laser, and allow the users to see that data before it even touches the ground, before it ever does a T or an ETL type process. Okay? And that's quite important to remember when we talk about these kinds of solutions. We actually have a customer in London, an investment bank, that is in production with this exact solution, in fact. But really what we're talking about then is taking what SAS used to do, analytics, making it high performance, giving you the ability to run things very quickly by embracing technologies like Hadoop and so on, adding in something called event stream processing, which is actually a product from SAS, but there are other ways you can do streaming, and allows us to put together those two things to give you the idea of streaming big data, high performance analytics. You could argue that there's a story behind how people work with this kind of system. So we put it up on the screen here and ask a few questions. So we could say, I have a lot of different types of data sources I want to grab from at very high speed. I need to get it quickly, and I need to do it in large quantities. So I could use a streaming solution for that. It could be event stream processing that you decide to use. I want to keep all the data as much as possible and make it easy to access, really fast for as long as possible. Some might use something like Hadoop to store it on the disks across a distributed architecture, and something like Laser, which is our in-memory capability to access it and cycle the data in and out of memory. I want to perform predictive analytics on the data and generate models that I can use. So then you can do that using some of the tools that are in-memory capabilities that come with SAS. And then I want to be able to deploy those models, and this is the really important part of streaming analytics. I want to deploy those models I've built into the stream, okay? Back where I came from, but with a model that can score as the data flows through it. Yeah? So there's a couple of quotes here. I'll just pick up well, it's actually one quote from Jerry Bullier, who's our Senior Director at R&D. Streaming analytics means making analytically informed decisions in milliseconds while examining many thousands of events per second generated from many millions of devices, which can also be enriched by many other disparate sources of data. It's quite a mouthful, but what he's really talking about, if you hadn't thought about it, is things like the Internet of Things, okay, sensor devices, things flowing continuously where you've got lots and lots of devices connected, all sending information all the time, mobile phones. All of you sitting here have got probably mobile phones in your pockets. They've all been transmitting to the towers where you are all the time if you're connected, right? So what is event stream processing and how does it work? The concept is, I don't know, we got stuck. There you go. So the concept is an event is a piece of data. You could think of it as a message, a time-based message, something temporal involved. You could think of it as, if you're looking at it from an SQL perspective, a row of data in a table could be equivalent to an event that you're passing through a stream. It's JSON messages, it's JMS messages, it's whatever kind of messaging systems that you need to collect data from. And it could be static data stored somewhere that you need to enrich the streaming sources with. So therefore, merging that data together in flight, okay? I must press the button harder. So if you ever want a full definition of what an event is, we've got a little bit more detail there. If you've ever heard of the term complex event processing, or CEP, which I'm sure many people might have heard of, that's actually what you derive from sub-events. You load something with loads of little events, bits of information that themselves may not be that useful. You merge them together while it's in flight going along, and at the end of it, you output something that you've derived, which is complex and more useful to you, right? Gives you more value. So there's that big data word, right? We finally got there. So why we've got it there is just to show you where we think, or where we believe streaming analytics fits nicely. It fits within that big data architecture that I showed you at the beginning. And of course, within that, we've got the Internet of Things to think about as well, because it can help us with those. And so because of that, I've put some pictures up on here. And what I wanted to do was to ask you to tell me what you think those three things have in common, other than the fact they're on the slide together. Anybody want to shout out? Jonathan?
Well, they're Internet of Things devices.
They are all connected devices, absolutely correct. They are all Internet of Things or connected devices. So you can put all these in your home. You can go buy those now. That Sky Bell you can buy from the US, have it delivered to you here, and you can plug it in your house and wire it up by the front door, and then when someone rings it, your iPhone pops open, and you can see them, have a two-way conversation, and then tell them that you're not in, right? Very handy, isn't it? The one in the middle, light switches and power sockets that you can put in your house that you can turn on and off from an app on your phone or from a mobile device, or any mobile device actually, or your web browser if you've got access to it that way. Very useful. You can buy those on various different websites, Amazon and so on. And the one on the end, the reason that's there is because everybody's seen one of those before. It's a Nest, okay? What is it? It's a way for you to try and optimize your heating usage in the house, okay? To reduce the cost for you to keep an ambient temperature. And there's various different apps that support that you can use out there. There's one for geofencing, so as you approach the house, it sends a signal to say, I'm close, and then the Nest says, well, do I need to put the heating on or not, based on your favorite temperatures. So those are quite clever things. The other thing they've all got in common is that I've got those, okay, all at home. The one in the middle is great fun if you're down the pub and you want to make your wife annoyed by turning on and off the lights, okay. So why did I show you those? Because they would fit in a house. And a house could be, with lots of connected devices, could be an ecosystem. You could think of it that way, a simplistic ecosystem. Here's a much more complex ecosystem, okay, of streaming sources, sensors. This is a Dreamliner jet. We've actually snagged this from the website, and there's actually 3,500 or more sensors built within that jet. And one of them, or several of them, are designed to adjust the flaps absolutely minutely as the plane's in flight to ensure, it says on their website, less turbulence for you. But what do we know they really are doing that for? That fuel economy. It wouldn't be worth doing if it didn't save the money somewhere, right? So okay, so it's really important. They're adjusting the flaps minutely, and that's analytics that's performing that in real time as the plane's moving. Down on the ground, we're receiving streaming data from the airplane, a collective of all that analytical information, down to sensors or screens where the engineers can check whether everything's performing as expected and perhaps even take action remotely to enable something to happen. A bit like in Formula One, right? Which is also a car, an ecosystem of connected sensors, if you like. In fact, your mobile phone is really an ecosystem, isn't it? Within a single mobile phone, there's lots of different sensors that pick up movement, tapping on screens, where you are at the moment, all that kind of stuff. So that's a sort of ecosystem as well. All of them transmitting all the time. So that's a lot of data. That's why we call it a stream, because all those things are transmitting continuously. There's lots of it. What could we use that information for? We could use it for lots of things. But before we get to the point of why we might use it, let's just have a look at the concept of streaming. I'm not really here to talk about use cases for why you might have it, but I'll just give you a couple of examples. So we have telecoms companies we work with who've used the concept of streaming analytics to pick up information from phones and to optimize the kinds of offers they send their pay-as-you-go customers so that when they send them the offer, it's not too late. The contract hasn't run out. They can actually receive the message that says, your data's about to expire. And then, believe it or not, they had a huge uplift on take-up rates of that because they were getting to the person in time for them to be able to spend money with them, which is great. Event stream processing then, there's a slightly different concept from what you might have seen before, or streaming analytics. The idea is you design a model of what you want to do. We could call that a continuous query. It's something you persist in memory. Inside that query, you've put transformations, tasks, and source data all together in one place, and you're doing something with it. With SAS, you can take our analytical models that you designed during your offline analytics mode, and we can persist those models into those little squares within the flow, which allows us to basically score data or do whatever you want to do with the data in flight. Why would you do that? Well, as we said earlier, you've all been sitting here while we've been talking. Do we really need to know that none of you have moved for the last 2 hours? Probably not. But if I'm trying to collect data, I don't want to get all that information. What I want to know is only when you move, and if you move somewhere that is interesting to an offer I want to send you, right? Maybe that is an interesting thing that I want to know about. So ESP can help us reduce that data down and then send it on to other systems consumers, such as real-time decision management tools or anything, campaign tools that make sure that we send somebody something relevant to the situation. So it's more about the state of now, isn't it? Okay? It might be that I have got a personalization record built up somewhere of Peter Pugh-Jones, and when he goes shopping in Waitrose, he always does this and this and this. I've got that history, but I want to know now. He's in Waitrose now. Where's he standing in Waitrose? Which stock is he more interested in? Which coffee does he just go and buy? Or when he gets to the till, he's bought all these other things and he's forgotten to buy the naan bread to go with his curry, right? All those kinds of things could be useful. So streaming allows us to take millions of records per second, flow them through a model, and output something more useful that we can use later on. So in order for that to happen, I'm going to do an example for you to shout out what you see. So we're going to have on the screen some dots. Each dot represents an event. It doesn't matter what the event is. And what I want you to do is tell me how many dots you see. Starts quite easy, okay? You don't really need to shout that one out, okay? Okay, here's some more. What are we doing? We're capturing information coming into an ESP engine, and we're asking it to do something with that data. Here's a few more. Okay. So what we want to do is get to the complicated bit. This is the sort of thing that an ESP engine is really good at. And if you're wondering where the concept of this technology comes from, it actually originates from the early 90s, or even perhaps earlier than that. Certainly if you're watching documentaries on Bletchley recently, you'll know some of the stuff in here is actually comes from that period. But this is the sort of thing you want to think about more. Multiple different types of events and seeing patterns in the data as it flows in very quickly. Okay, so here we go. Time-based problem. How many yellow dots appear on the screen after the blue dots. Hopefully it will trigger. There we go. So what I'm trying to do is say, it's quite difficult for us to do that as humans, isn't it? But that's what this product's designed to do, and that's what streaming products are designed to do for us. What other kind of use cases might you have? Well, maybe you want to predict how many red dots there will be next based on either the history that you've seen in the past or a combination of the history you've seen in the past and predictive models that you've put inside the flow to make it come up with some values. If there were 20 red dots, put the next 3 blue dots in a specific category. That's kind of bucketing of data, isn't it? Moving things around, something you might do in ETL perhaps, right? If there are 10 blue dots, go and look at another data source and see how many blue dots there are in total when you join the two together. That's a sort of aggregation task, isn't it? And then finally, if there were 6 green dots, wait for an hour, then compare again. That's the sort of thing that you might do, as I said, in the banking industry, where we also use this quite heavily. So when you're doing things like Bollinger Band calculations or MACD stuff, you have to take with data, retain it for a period of time. You have a window at 5 minutes, 10 minutes, 15 minutes, and you do some math on those windows to give you some idea of what might happen next with the stock that you're analyzing. Okay? So use cases, very high level. The reason this is general is because actually, across industry, there are loads of places where you might take advantage of streaming analytics. We've got a company in the US that's looking at our event stream processing to analyze the noise that carriages of trains make when they connect, store that correct noise in memory inside ESP, and then flow all the sensors noises that it's collecting from all the trains connecting to check that they sound the same as that noise. Obviously, making sure they don't sort of get false positives and so on. But that's a really good use case. Cybersecurity, it's a huge area for, as you can imagine, for a technology like this. Looking at people's activity over time on the network within a company, and perhaps over time analyzing what their patterns might be and what categories they fit within. And then, if something strays or they become outliers from that norm, that might be a hint or some information to tell us that there's someone breaking in and pretending to be that person. Could be a possibility. Telecoms industry, we already talked about. Risk management and cap markets are all places that we use it. And within the industry, we've got companies, and again, a large oil and gas company using it to help us decide whether sensors are failing within the oil rigs and sort of come up with, rather than waiting for them to fail and building that lifetime into them, actually trying to work out what's the closest point we can go to by predicting that it's going to fail tomorrow, that kind of thing. Okay. So hopefully that was a reasonable insight for you. And should you want to contact me and talk to me about it any further, I'll be around for the rest of the day. My email's up on there. I assume we share these slides out, right? So that's good. So please feel free to get in touch. Thanks very much. So yes, we've got a 5-minute question session. You can always catch us later, I suppose.
Yeah, we'll be around later.
Obviously, we don't want to hear the word big data.
Oh, hi. Jonathan, I'm not that well versed in this stuff, but you mentioned in your talk about analysts spending a lot of time sorting out the data,
Yeah.
and your slide indicated that you could produce a schema, or Hadoop or tools could produce a schema automatically from CSV data. Could you expand on that a little bit more?
Yeah, that's just an inbuilt, it's an inbuilt function of the way R reads its data, and then in combination with Spark, it'll tell you what you've arrived at based on the data that's come in. But if data comes in with headings attached and data dictionaries, then you're away and running. Frequently it doesn't, and therefore your job is to hunt back through where it's come from. And in some cases, to be honest, the definition of your data dictionary and what you receive when you're working on data sets can be as rudimentary as, well, you better go and ask Steve because he built this, he designed it 17 years ago, and we think it means this. So there is a lot, the whole exploratory data analysis phase and where this stuff kicks in is it allows you to process well-structured data that you know about really quickly, but it also allows you to get to those things in the data sets that perhaps you weren't expecting. I certainly wasn't expecting, I don't know why, but I wasn't expecting to find balloon flights in 20 odd years, 25 years with. But it makes perfect sense because balloon flights have an impact on commercial flights and could be regarded as a commercial flight. So yeah, there's a lot of work that analysts have to put in shaping up the data. It's basically getting familiar with it, and the tools help you to an extent. But Steve from 17 years ago was usually the winner.
Well, you didn't run it in COBOL, right?
Oh, I get questions from you every day.
It's okay, it's to Peter. It's Ewan Robertson, Aquila Insight. I think there's two phrases that get a bit of bad press. We've touched on one of them, which is big data. I think the other one is data scientist.
All right.
Because I'm amazed at the number of people overnight from being a business analyst, I immediately became a data scientist. However, Peter, in your opinion, what are the fundamental skills that would differentiate, let's say, an analyst from a data scientist?
That's a really good question, actually. I think I don't know if the same commercials run up here, but there's one on TV in the UK at the moment. So sorry, we are in the UK, in London at the moment, which is a recruitment website, a recruitment company, and they focus on this guy who is an IT engineer, and they steer him through this sort of cloud of stuff to this big shiny sign that says data scientist on it. And I'm thinking that's an interesting sort of change of journey. I mean, you know, that's very strange. So I agree with you. It is a very mixed up. I don't think, in truth, I don't think anyone's really defined exactly what a data scientist is. I think data scientists have to have really good analytical capability if somebody's going to be in that sort of role. But I also think you actually have to understand the technology as well and how the stuff actually integrates together to give you the capabilities you want, especially when you're looking at some of these sort of Hadoop type infrastructure, which is not something that someone without an IT background can suddenly just start using, unless they're using something a little bit like SAS maybe with a UI on it, which means they don't have to sort of write code and make everything go together. So I think I don't know if it's been fully defined yet. You see jobs in the newspaper for a data scientist at 20K, and then in London, and then you see another one for a data scientist at 120K, and there's no difference in what they're asking for. So it's very difficult to know. I don't think they really know themselves. So my opinion is that I don't think it's really properly classified yet. But one customer we had did actually say, I'm not going to have a data scientist, I'm going to have a data scientist team, and that team of people will be together. They will comprise the skill set that I believe needs to be the data scientist. If that makes sense.
Thank you very much.
Okay, my pleasure.